Good afternoon. Seems we have less students than I expected. So, anyway, never mind. On Monday, we discussed about the multiple unit processes, right? So, if we have two units, and then we can, this is the flow chart of the with the two unit processes. And then we need to find out how many systems we can have. So in order to solve the problems with the input equal to the output. Right, so I hope you already know this because this is important. For example, since you are early bird, let me just give you an example of number one. Okay, can anybody tell me how many input and how many outputs? 0.5. Yes. And how many outputs? 2 outputs. I'm sorry. 3 outputs, right? Okay, good, good. Right, 0.5, good. Early birds. Number 2, how many input and how many output? 0.5. Number 2 here, how many input and how many output? Yes. And okay, good, good, very good. Right, congratulations, early birds. So you need to know that you need to find out how many input and how many output in order to do input equal to output, right? General variance equation. Okay, right. So and on Monday we learn liquid-liquid extraction, and I already show you a video. And you know what is liquid-liquid extraction. And I just want to show you that one of the important example, this one is that, show you one of the important example is, for example, this is the one, right? This is the one. Right, MIBK will take out acetone from the mixture of the acetone and water. Remember? So this is what, this is water, this is acetone. So these two can mix very, very well in any proportion. But in order to separate these two, you cannot use distillation current, right? You have to use MIBK to do the liquid-liquid extraction first. So for example, if you put these three things together, for example, in the beginning you have two this, and you pour this liquid into this mixture, and then this one will dissolve in this solvent, right? As a result, you can take this out, and become 2 layers. So you can, and then and you can have pure water, for example, not pure, probably a high proportion or high percentage of the water in the liquid, right? And then you use distillation to separate these two. I hope you still remember this. So I already show you a demonstration, right? So this is liquid-liquid extraction, and you have a mixture of A and B here, and you put the third solvent or third liquid into this mixture, and then you shake it. So like this one, the material in this layer will come out to this layer, right? And you can take out using the beaker. So, and then you have this part you can use, this is a mixture of the C and B, right, for example. And then you can use distillation to separate B and C. Okay, so today, let's directly go to the example 4.4-2 because this is important, and I think this will be in your midterm exam paper. So you already have a rough idea of liquid-liquid extraction, right? But this is what you use in the laboratory. Of course, in the industry, you don't use this kind of laboratory scale to separate mixtures. So we have a mixer first. So you mix the mixture of A, B with the C together, and you let the things settle down. So you become 2 layers, right? So for example, the feed here is water and acetone, 50-50%. So you feed into this mixer, and you pour in the MIBK, right? So this is, we carry on the liquid extraction process. And then because you want to make the things quicker, so you discharge this mixture into a settler. So you let the thing settle down. It takes time, right? It takes time. So this layer, it will become 2 layers because MIBK and acetone will become 1 layer. Which one is the MIBK and acetone will be 1 layer, and water will be another layer. Which one will be in the bottom? MIBK or water? Which one? MIBK, right? Because MIBK is heavier. Okay? So settler, and so you discharge this called extract number 1. Extract number 1. The extract number 1 here is mostly MIBK and acetone, right? Because MIBK take out acetone. So this is extract 1. And then you have raffinate. Raffinate number 1 will be mainly water. So mostly water. But however, if you don't mix these 3 things very well, or because of time consuming, because it takes a long time. For example, if you can take out 80%, it only takes 10 minutes. But if you want to take out 99%, it takes 1 day. So you don't have time to spend 1 day for the industrial process. Because time is money, right? So you only want to spend 1 hour or 10 minutes to separate these 2 within 80% efficiency. So of course you will have 20% of acetone here. Okay, because you want to run this efficiently. So in that case, you might need another mixer, right? Because there are about 20% still in the raffinate, of 20% of acetone still in the raffinate. So you want to have another mixer. So you pour in the MIBK into this mixer again. And again, it might take 1 hour to take out the rest of the acetone. Again, you need a settler, right? So, and then in this case, MIBK and acetone will again in the extract number 1. So mostly MIBK, acetone, and water. Right? You will have some water here, for example. And then in the raffinate, you will have water, 93.1% water mainly, right? This is water mainly. Okay, and some of the MIBK and acetone. Okay, so in this case, if you are not happy with 91, if you are not happy with the percentage of MIBK and acetone in this case, you will have the 3rd extractor, right? This is number 2 extractor. This is number 1 extractor. So if you want to have high percentage of water, you can have a number 3 extractor. Or if you're not happy, then you can have a number 4 extractor, number 5 extractor, right? So it depends on how much money you spend, or what's the purity you want for the water or for the process. Okay, and because here you got the mostly MIBK and acetone in the extractor 1 and extract 1 and extract 2, so you mix this together. And then because this is MIBK and acetone, you can use distillation column. You can use this later to separate MIBK and acetone, right? So this is called combined stream, combined extract. Mostly A in feed M. M stands for MIBK. A stands for acetone. Okay, in this case, because of the huge differences in boiling point between acetone and MIBK, you can have acetone on the top stream, and then as a product, and then you can have MIBK in the bottom stream. So mostly MIBK, some of them acetone and water. So in industry, you don't get 100% purity, but this is probably good enough for the industrial process. Okay, in the laboratory, you might say, well, professor, I want 100% purity of the acetone and 100% purity of MIBK. But in the industry, because consuming and time is money, and you had to build up many reactors, many processes, which is not cost effective. So that's why this is the acceptable process with the 2 extractor and 1 distillator, for example. Okay? So I hope you understand this extractor distillation process. So, however, in our textbook, this mixer and settler, we can call this extractor 1. So we combine this, make it simpler for you. Okay, so this is number 1, this is number 2. Okay, so this is number 1 and this is number 2. And you have number 3 here, number 3, and number 4. So you, the textbook try to make the question easier for you. So they make it like the 4 units only. Okay, so as a result, we make it like this. From here, that become extractor mixer together with settler. Let's become extractor 1. Mixer and settler become extractor 2. So we have something like this. So as you can see from your textbook, page 98, so it become like this: extractor 1, extractor 2, and distillation column. This is a joint point from the extract 1 and extract 2. Okay, so it looks like this. So this is mixer 1, mixer and settler become extractor. So now let's think of how many systems. First, individual units. How many systems for the individual units? 1, 2, 3, 4, right? 1, 2, 3, 4. So each system you can do input equal to output. Right? Each one you can do input equal to output. So individual unit 4. Okay, so let's think of how many 2 combination units. 2. So you need to put 2 units together and make it become a system. So how many systems? Can you tell me? 1, 2, 3, and 4. So 2 unit system, you have 4. 1, 2, 3, 4. 4 here, right? Again, let me show you one more time. 1, 2, right? 3, and 4 is here. So you have 4 2 combination unit system. So how many 3 combination unit system? How many? 1, 2, 3. How many? 3, right? Okay. And then do we have 4 combination unit system? Yes. Because we have 2 units, right? So that will be overall unit system or 4 combination unit system. How many? 1. Because this one, you have this. So if you count overall unit system, how many input and how many output? Please tell me. How many input and how many output in this system? How many input streams and how many output streams? 3 input streams and 3 output streams, right? Because this is what we call hypothetic box. And you have something outside this boundary, which is 1, 2, 3, and 1, 2, 3. So 3 input and 3 outputs. Okay. All right, so now let's work together with this example. Do you have a PDF file? No. Okay, have a book, and then or you can. If you have PDF file, you just have it with me, and or you can print out, right? 你可以印出来，你可以在你的 PDF file 上面看，或者你去借课本，对不对 ？Okay, so let's work together with this problem. Okay. So let's go. The page example 4.4-2 on page 97. So the title is extraction distillation process. Okay. Okay. So the first line is a mixture containing 50% acetone and 50% water is to be separated into two streams, right? Okay, so you know input will be 50-50, right? 50-50. So one rich in acetone and another one in water. Okay, so you need to be separate into two streams. Okay, and then the separation process, the second paragraph, second paragraph, the separation process consists of extraction of the acetone from the water into methanol isoprene ketone. We call MIBK, right, or M, which has a much higher affinity for acetone than it does for water. So what does that mean? MIBK can take away acetone from water, right? So the process is shown schematically below. So in your midterm, exam, I will give you this. No, I don't give you this flow chart. I will give you the flow chart on the page 98, like this, like this in the I'll give you this flow chart, okay, in your midterm exam. Okay, so let's go to the next page, page 98. The acetone solute, water is dilute, right? Mixtures is firstly contacted with the MIBK solvent in a mixer that provides a good contact between two liquid phases. A portion of the acetone in the feed transfers from the aqueous phase to the organic phase in this step. The mixture passes into a settling tank, where the phases separated and are separately withdrawn. The phase reached in the dilute length, okay, is referred as the raffinate. I already show you this, right? Okay, and the phase enriched in solvent MIBK is the extract. The mixer settler combined is the first stage of the process of this separation process. Okay, the third paragraph. The raffinate passes to a second extraction stage where it is contacted with the second streams of the pure MIBK, leading to the transfer of more acetone. The two phases are allowed to separate in a second settler, and the raffinate from this stage is sent to a waste treatment operation. The extracts from the two mixer settler stage are combined and fed to a distillation column. The overhead effluent is rich in acetone and is the process products. The bottom effluent is rich in MIBK and in a real process would be treated further and recycled back to the first extraction stage. But we will not consider recycle in this example. Okay. In your midterm exam, I don't think I won't show you these paragraphs. Okay, these three paragraphs. So in your midterm exam, I will show you in the following paragraph. Okay, Okay, let's work together and then let's read the numbers together, and we will put the information in the flow chart in this slide. Okay, so in a pilot plant study, for every 100 kilogram of acetone water fed to the first extraction state. So when you read this, 100 kilograms of the acetone water fed to the first extraction state, that means what? You might think, wow, good. I have 9 steps to solve the problem of this input equal to output, and then the first step is choose a basis. So 100 kilograms, it should be the basis, right? Okay, so please take a look of the slide here. So I will say that let's write down the information we got. So we have 50-50, right? 50-50. Sorry, in the very beginning. Okay. I'm sorry that. So in the very beginning, I think I might show you all the paragraphs in your midterm exam. Anyway, so the first paragraph is 50-50, right? 50% acetone and 50% water, and you have 100 kilograms in. Look at this slide. 100 kilograms of the mixture. Okay, and then 100 kilograms of the first line, in the end of the first line, 100 kilograms of the MIBK is fed to the first stage, and the 75 kilograms is fed to the second stage. So you understand in the slide here, you can write down 100 kilograms MIBK in the first stage, right? You write down here in the flow chart, and the 75 kilograms MIBK write down in this the second extractor. Okay. So I write down like this. Okay, the line in the end of the second line, the extract from the first stage is found to be contain 27.5% acetone. Blanket. All percentage in these reminders of these paragraphs are weight percentage. So it's weight percentage, right? So you know that we are talking about this one. Extract. So we have what? We have 27.5% acetone in this stream. Okay, if you take a look at this slide, I will show you the information here like this. Okay. Right. So the second stage, so the line number 4, the fourth line, the second stage raffinate has a mass of 43.1 kilograms and contain 5.3% acetone, 1.6% MIBK, and 93.1% water. So they tell you what? They tell you the second raffinate. This is second raffinate, right? This line is we call second raffinate here. So they got us the information of what? 43.1 kilograms, and you have 5.3% acetone, and then 1.6% MIBK, and then 93.1% water. Right? This is information we have got. Okay? Right. So let's go to the number 1, 2, 3, 4, 5. Line 5. The second stage extract contain 9% acetone, 88% MIBK, and 3% water. So this is the second extract, right? Extract number 2. We got 9% acetone and 88% MIBK and 3% water. So write down all of the information you know. And the last sentence in this paragraph, the overhead products from the distillation column contain 2% MIBK, 1% water, and balanced acetone. So the overhead products from the distillation column, where is that? This one, right? This one, overhead. This is the top stream. This is bottom stream of the distillation column. So when you take a look at the slide, here you need to put all the information here. So why is that? So it's so you have 2% MIBK and 1% water, and then 97% acetone. That's all you have information. Okay, these are all the information you have got. Okay, so the next paragraphs, taking a basis of calculation of 100 kilogram acetone water feed. So you already know this is a basis, right? And then they want you to calculate blah blah blah, calculate the masses of the and the composition blah blah stage 1. So these are the information you need to know, and then you need to solve. So before we really do this, we need to write down all the unknowns, right? We need to write down all the unknowns in this flow chart. So, okay. So this is the flow chart and all the information we have got in this example. So let's do this one by one. This stream, do we miss any information? Do we need to put any unknowns in this stream? No, we don't, because you have all the information, the 100 kilogram, and you have reached a fraction, all right? 50-50, 50% acetone, 50% water. So this information, you have complete this information here. And how about this one? This is MIBK. MIBK has no proportion, have no fraction. But this is pure, right? MIBK is pure. So 100 kilogram pure MIBK. So you don't need to put any fraction here. Fraction of MIBK is 100% anyway. Okay, how about this one? Extractor number 1, you have raffinate, you have extract number 1, right? So this is only one you got. So what you need to know to put is what? You don't know the amount of the mixture come out from this as an extractor 1. So you write down M1, M sub 1, number 1, which is kilogram. And this is the total amount of the extract number 1. So you need to have what? You need to put some of the information about for the fraction. So acetone is 27.5%. So you don't know which is X, right? X, you have M1. M1 means what? This is the extractor 1, so you use M. M stands for MIBK. And then others are water. So you have 3 things here. So why, you might say, well, Professor, why you don't put this in, you don't write it down in red color? Why? Because, you know, this is called physical constraints, right? Because 20.75% and this plus this equal to 1. So once you know this, you have only 1 unknowns in this place. So as a result, you only have 2 unknowns in this stream. Okay, this is total amount. This is the fraction of the MIBK. You might say, well, Professor, I'm not happy. I want to use water as an unknown, which is XW1. That's fine, and this will be 1 minus 0.275 minus XW1. That's okay. That's okay. But what I suggest is don't give teaching assistant trouble. When you start to mark your score, when you start to try to examine your, try to score your paper, you don't want to give him trouble, right? Because if you give him trouble, you'll get less point, right? So you want to please him, right? So what I suggest is, this is what we suggest. This is what textbook suggests you to do it. So you need to, you can do it in another way, but my suggestion is try to do it as what textbook told you how to do it. Okay, so you already complete this stream. Okay, next stream is here. Next stream is here. So you don't have any information about this stream. So you can write down all the things unknown, which MA2, A stands for acetone. This is MM2, this is MW2. So you complete this information here. How about this one? There's no information missed. So I go to this one. This is roughening number 2, and you have everything. You have total amount, you have fraction of the acetone, water, and MIBK. So you don't need to write down any unknowns in this stream. And how about this one? You have 3 informations. You have the fraction of the MIBK, water, and acetone. So all you don't know, the things you don't know is the total amount, which you write down M3. So M1 and M3 get together, become this line here. So the things you don't know is M. You don't have any information like this stream. So you have MA4, MM4, and MW4. So this stream will be fed into the distillation column. And you have last 2 streams left here. So one is top stream, which is the product of the acetone, right? And bottom stream, which is the product of MIBK. So on the top stream, what you don't have information is the total amount in the top stream. So you just write down M sub 5. And for the bottom stream, there's no information provided. So you can write down MA5, MA6, MM6, and MW6. So these are all the information you will have got with the non-variables and the unknown variables. Okay? So after that, you finish step 4, and now you need to do step 5. Remember step 4, step 5, DOF. Can you get the answer of all these unknowns, or can you get all these unknown variables? Can you? That's the things you need to do first. So I made this flowchart smaller, look like this. And let's do it step by step. Remember, basis, flowchart. Write down flowchart and give some and do a DOF analysis. Okay, do a DOF analysis. So for overall process, again, we always do the most important simple case first. So for the overall, please tell me how many input and how many output. You already got answer, right? How many input and how many output? 3 input, right? This one, and then 3 output. This one. So how many unknowns? Anybody want to tell me how many unknowns in this overall process? How many? Raise your hand, 0.5. How many unknowns, ladies and gentlemen? You have 3 input and 3 output. Can you count unknowns for me? 0.5. Yes? Huh? 13. I'm sorry, it's not correct answer. I just want to ask you, because inside the box, if you regardless of the unknowns inside the box, you just want to count unknowns outside the box. So anybody want to tell me how many unknowns? Yes? 4, right? Yes, thank you. If you have 3 input and 3 output, these 4 are the unknowns. Right? This is outside the box. Right? Outside the box. 3 input and 3 output, you have 4 unknowns. So if you do DF, you have 4 unknowns. M5, MA6, MM6, and MW6, which are these 4. Okay? And then how many equations you can create? Because DOF is unknown minus equations. So you have 4 directions to find out equations. First one is how many species it is in this process. How many? So you can do input equal to output, right? Water input equal to water output. Acetone input equal to acetone output. With these 3 input and 3 output, right? And then 3 input and 3 output streams. And then what else? MIBK input equal to MIBK output. So you can create, you have 3 species, you can create 3 equations. Okay, this is first direction. The second direction is what? Second direction is what? Specification, which is related to what? The relations between each stream, unknowns with each streams. Do you have any specification in this example? No. So far, when you read the textbook, when you read the example, there's no specification. So specification is 0. Okay, this second direction. The third direction is what? Physical laws, right? Any density relations, any molecular weight. Do you need to convert value to mass or convert mass to mole? Do you have this information? Do you need to do this information? No, you don't, because all the streams related to liquid, so they all use mass, kilograms, to represent the mass. So you don't need to have any conversion. Okay, this third direction. The fourth direction is what? Physical constraints. This is physical constraints, right? You already got this. So you already have one, so it's not counted into the unknown. So these are the 4 directions you need to know. So as a result, it's 3 species, 3 equations. And then no specification, no physical laws, no physical constraints. So the total equation you can create is 3. So you can create 3 equations. So can you get the answer of this number, these 4 unknown variables? No, you cannot. No, you cannot. However, this might be temporarily correct. You cannot. But you don't know, because you just try to find out one system only, right? Overall system. Probably you can use single system or multiple unit system to solve these 4 unknowns. You don't know. But anyway, let's go to the next page. And again, DOF analysis is you start to use single unit system. So how many single unit systems in this flow chart? 4 single unit system, right? Remember? 4 single unit system. Okay, let's go through the number 1 first. How many input and how many output? 2 input and 2 output, right? 2 input stream and 2 output streams. How many unknown variables in this case? How many? I'll give you another chance, 0.5 point. Please tell me how many unknowns in this case, in this box, outside this box, how many unknowns? No? Yes. 5, yes, thank you. 1, 2, 3, 4, 5, right? You have 5 unknowns. It's here, the answer is here, right? Am I right? So, probably 0.5 point is not important for you. I don't know. Why nobody raise your hand? Okay? Or my English too poor. You don't understand my English? No? Okay. Thank you. Okay, you have 5 unknowns in this system. So how many equations you can create? 4 direction, right? But you already know there is no physical, there is no specification, there is no physical laws and physical constraints. So the only thing is 3 species. You can create 3 equations. So the answer DOF is 5 minus 3 equal to 2. DOF is 2. So again, there's no way you can find out these 3 unknown variables using this system. Okay, let's go to extractor 2. So extractor 2 is here. So how many unknowns here? 4, right? 1, 2, 3, 4. You have 2 input and 2 output. You have 4 unknowns. So if 4 unknowns here, how many equations you can create? You can have 3 again. I'm sorry. 4 minus 3 equal to 1. DOF is 1, is not 0. So you cannot get the answer of these 4 unknown variables. Okay, let's go to this one. Do it step by step. Mixing point. How many input and how many output? Streams. 2 input streams, right? And 1 output streams. So how many unknowns in this case? 6, right? 1, 2, 3, 4, 5, 6. That's 6 unknowns. Again, there's no way you can get the answer of these 3 unknowns using this hypothetical box or using this in this mixing point. Right, distillation column, distillator. Okay, you have one input stream, 2 output streams. 1, 2, 3, 4, 5, 6, 7. You have 7 unknowns. Again, there's no way to find out the answer you want. Okay, so you give up. No, you don't. You don't give up. So let's go to the mixing. Mixing the 2 combination or 3 combination unit system. So this is the key for you to get correct answer in your midterm exam. So let's see the combination of the units first. Of course, we got this fruit too first, easier, right? So extractor number 1, extractor number 2. Please tell me how many input streams and how many output streams. 3 input streams and 3 output streams, right? 3 input streams and 3 output streams. And please tell me how many unknowns in this case. You don't count the unknowns inside the box. You only count unknowns outside the box. With this 3 input and 3 output streams. So you have 1, 2, 3. You have 3 unknowns. Wow, it looks like you can get the answer of these 3 unknowns because you can create 3 answers. So to extract the subsystem, you have 3 unknowns, which is M1, XM1, and M3. So you have 3 unknowns, and you have 3 species, which are water, acetone, MIBK. So water in these 3 streams input equal to water from these 3 outputs. So we can get 1 equation, and the same as MIBK and acetone. So you can get answer of these 3. Can you do that for me? Input equal to output. This is very easy, so I don't want to waste your time. So, and all I want to show you is that in your PowerPoint, in your PDF, this show white color. This show this showing the what's that? Blue color, right? So that's what I did. So once you get the answer, you make it become white. You make it become blue. Let me show you again. This become blue. This become blue. So this become blue. This become blue, and this become blue. Okay. And you might say, "Wow, Professor, can I go back to one unit system which is easier?" Yes, you can. Why not? You don't want to do another combination unit system because it gives yourself trouble. So you can do what? You can do extractor and mixing point. So you can do this, or you can do this, right? As you can see, there are only 3, right? But the textbook tells us that do extractor and mixing point. So extractor and mixing point here. So please tell me how many input. 3 input stream. How many output stream? 2 output stream, right? 2 output stream, 1, 2, 3 input stream, 1, 2, 3. Okay, so please tell me how many unknowns, how many unknown variables. 3, right? 1, 2, 3. So you have 3 unknowns, and you have 3 equations, which are water, acetone, and MIBK. 3 equations. So you can get an answer of this one, these 3. I change the color from red to blue, so that means you can solve this problem with very easy 3 equations. Okay, so the extractor number 1. So now you go back. You can go to extractor number 1 with the mixing point here. Of course, you can do something like here, or you can do it here. But example tells us that this example tells us that you do it this one. Extractor 1 and mixing point, which is this one. And please tell me how many input? streams, 2 input streams. How many output streams? 2 output streams, right? This one and this one, because this is the mixing point and the extractor number 1. Okay? So you have 3 unknowns here, and then 3 equations. Yes, you can get the answer of these 3. This is for DOF analysis. And now there are 4 unknowns here. No matter what you do, you cannot have 4 equations. Because now you see that 3 equations, 3 equations, 3 equations. So there is no specification, there is no physical laws and physical constraints for you to consider to create other equations. So there are only 3 equations. No matter no matter what kind of system you make, you cannot solve these 4 unknown variables. Okay? So in your midterm exam, I will give you extra information so you can get the answer. Or I might just change the numbers. Like for example, 50-50, I say 45 and 55. Excuse me. So so that will be you need to practice. You need to practice more, and then you can get the answer. Okay. So after that, after DOF, you do the calculation. So in your midterm exam, I want you to show me you understand the meaning of DOF. So you need to write down DOF equal to what, and then start to get answer. Otherwise, you don't get the full points. I might deduct some points from the question. Okay. So again, I don't want to waste your time to do the calculation with me. So you go home and start to practice by yourself. If you practice 3 times, I guarantee you can get the points in your midterm exam. Okay, so don't be too lazy not to practicing this example. Okay. Right. So so this is the section 4.4. Okay. So let's have a quick. Let's have a little. Let's have a rest first. Okay. So so this is section 4.5. Recycle and bypass. Recycle in Chinese is 循环, bypass is 绕道. So we are going to learn about this. However, let's go back to the previous example. This is the extractor 1, extractor 2, and in the end, we put in the very beginning we have a mixture of water and acetone, right? So you have mixture, and you want to separate water and acetone. So as a result, the water will come out in this stream. So we fit MIBK in this one, MIBK in this stream, right? MIBK 2 here, and then as a result, we got 3 products, 3 things. The water come out from this stream, right? And then acetone come out from this stream, and MIBK come out from this stream. Although we have water and acetone mixture and MIBK, in the end we'll get something like this. So this is the products. Acetone can be reused, can be used for other applications, right? Okay, and water, if you don't like this water, you just discharge it in the river or something. I don't know this is allowed or not. Okay, you have a little bit amount of MIBK and acetone. Anyway, this is very like water already. Okay, how about MIBK? You just discharge it, or you just waste it. No, as an engineer, you want to save money. Everything can be used. This can be used, this can be used. And how about MIBK? That's why we say recycle. Because you don't need to have pure MIBK to be in the extractor 1. You don't need to have pure MIBK in the extractor 2. You don't mind there are some small portion of acetone water in this mixture, right? It just fit into this MIBK. You make the process more efficient and save money, and you can reduce the cost. So this is why we say recycle. So the recycle is not really pure things you think, well, I just recycle it. This recycle can make money. Okay, as a chemical engineer, you need to think how to make money, right? Okay, how to make the process efficient and then also get some perfects. Okay, so the description. You must. This is another example. This is a reactor. So it is a rare a chemical reaction A to B persists complete in a reactor. So if you want to convert A to B, probably 1 hour, the conversion is 80%. For example, 1 hour in the reactor, you might have 80% B and you have 20% A. But if you want to convert this 100%, it takes 1 year. Do you want to run this reaction within 1 year, or you want to run this equation within 1 hour? Which one? Of course, 1 hour, right? Because you don't have 1 year to wait for the completion of this reaction. So, and then what can you do? So this A to B, A and B, right? So the good thing is, can you build a separator to separate A and B? And then to make, and then you got product of B, right? And you recycle A. So and this probably takes 1 hour or 2. So 1 hour equal to 2 hours, for example. Instead of spend 1 year to get A conversion to B completely, reacted to become B completely. You can build up like this. The things you want to think is how much it costs to build a separator. If it take a very cheap, if it's not too much, if it's not too expensive, of course you want to build a separator, right? So this is called recycle stream. So recycle back A to the reactor. So recycle is that you need to pay what? Pay for the separation and recycle equipment. So the separator and its pipes, right? Recycle equipment. And then you can, of course, this is A recycle, right? So you can purge less. Of course, in the very beginning, you might have 100 kilogram per minute, per hour. But if you recycle 10, so you can have what? 90. So you can save money to purchase less fraction reactants and being able to sell purified products at a higher price. But because you save money, so you can sell higher price. You can have more perfects, right? You can make more money. Okay, so because this is the first year, you don't need to know how to design this reactor. You don't need to know how much money you need to spend. But what you need to know is how to do input equal to output. How to do mass balances. So how many systems here? How many single unit systems here? 1. This is joint point, right? Stream A and stream 1 and stream 2, right? This is 1, 2, 3. You have 3 single unit systems. Okay, 1, 2, 3. And how many 2 single unit systems? 1, 2, right? Okay. And this is overall unit systems, just like what we have in the equation of Kahoot. Right. So the figure 4.5-1 recycle A and B is, for example, this is the example is 200 kilograms A and 30 kilograms of B. This is from recycle joint point from recycle stream. Okay, so reactor here and then you do the conversion. There's no 100% conversion rate, but B can increase, A will decrease after the reaction, because A will go to B. This is a reversible process. Okay? And then you have 100 and 130 of 100 kilogram A, 130 kilogram of B, and you do the separation. And you cannot separate very well. Anyway, it doesn't matter. This is the product. You have 10% A, so the efficiency is what? Probably 90%, for example. And then you have 90 kilogram A and 30 kilogram of B. So this had a majority of the species in this stream is A. So we just recycle. Okay, this is called recycle stream. So in the very beginning, fresh feed is 110 kilograms of A. You can input a pure fresh feed. So as a result, you know that this is 200, right? This is 110. Another 90 is from this recycle stream. Okay? And because you feed the less input of the fresh feed, you save money, and you can sell more. You can sell high price with the products, right? Okay, so this is example 4.5-1 material and energy balances on an air conditioner. We use air conditioner in the summer every day, right? So what's the air conditioner? This is not a reactor, so why we need to use air conditioner to get this answer? So the fresh air, air conditioner is energy exchange and also material exchange. Because what? Because the hot water will come in and cold water will come out. Hot air will come in and the cold air will come out, right? And what else? Water, right? So if you have an air conditioner in your dormitory or at home, there's a small pipe, and the water always come out with that small pipe, right? Why? Because the condensed water in the air will be condensed, become liquid water, and then you need to have a container to remove this water. So the fresh air always contain water, or we call vapor. So this is a 4% vapor, right? And of course, there's 96% dry air. Should I read this with you together? No, I think okay. I think I don't read the sentence with you because of time. So I just wanted you to know that this is the input 96% dry air. dA stands for dry air, and 4W stands for vapor, water. Okay? And then, as a result, it comes out 1.7% water, and then 98.3% dry air. You might say, well, Professor, why not 100% dry air? It's just too dry. You let you feel very uncomfortable, right? So you don't want to have a very excellent air conditioner to have 100% dry air to come out as an output. You don't need to have so good that one. Okay? So this is the air conditioner. And then you have water. As a liquid, right? And then the thing is that you have dry air to fit into this joint stream, and which is 2.3% of water, and then 97.7% dry air. So you know that if you do this is called recycle stream. You might say, wow, Professor, why we need recycle stream? Can we just fit this fresh air into the air conditioner without recycling? Yes, you can. But can you see the concentration of water? if you put the air in, if you put this air into this, fresh air into this air conditioner without recycle, can you come up with this proportion of the water? No, you cannot, because as you can see, you reduce the ratio of the water, right? That means what? The air conditioner doesn't need to be too good as long as there is a recycled stream. So for example, if you want to convert the water 4% to 1.9% or 1.7% water without recycle, it might take you, for example, 40,000 NT dollars, right? Okay, but that means air conditioner should be good, but you don't need to spend 40,000. Okay, because if you have recycled stream, the concentration of water it won't be that high, so you can reduce the price. Okay, the air conditioner doesn't need to be so good. Okay, so you can buy a little bit cheaper air conditioner, for example, 20,000. So you can get the same quality of the air. Okay, this is the recycled stream. So you want to spend 40,000 or you want to spend 20,000? Of course, 20,000. That's why the businessmen, they think that, oh, you want to buy cheap products, so I'll give you a recycled stream. So you get the same performance. Okay? So the reminder is what? So the reminder is that this 4.5-1 tell you that the basis is 100 here. Okay? So, and then here is, I want you to know that if you have a recycled stream, so this is all the information we got from the textbook. So now let's write down the unknowns in this flow chart. The first one, let's do it one by one here. So the unknown is here, M1 here. How about this one? You have ratio of the dry air and the water. So you have M2 here, right? Okay, and this air conditioner, and then you have something, and do you want, this is a pure liquid, right? Pure water, so it's 100%, so you need to, there's no unknown in this stream. And how about here? Of course, there's no fraction, so you need to have one unknown here, only pure water. And this stream is what? Number 4. But you need to know the ratio of this. So what is this ratio? It's known or unknown. Ratio of this stream is known or unknown of the dry air and water. As you can see, this is a kind of splitting point. This stream come out, split into 2. So this splitting point, so the ratio of this should be equal to the ratio of this stream, right? So this is 1.7% water and 98.3 dry air. So this ratio will equal the ratio in this stream will be ratio of this as in this stream too. And the recycle here is what? Yeah, M5, right? This is M5, is total amount of the water and dry air. And again, you need to know the fraction. The fraction of the dry air and the fraction of the water is what? The same, because it's splitting point, right? So this again, that will be 98.3 and 1.7. Okay, so this is not unknown. This is known, because the splitting point, the ratio should be the same. So can you get, so how many unknowns in this total? 1, 2, 3, 4, 5, right there, 5. So can you get these 5 unknowns for me? Can you solve this problem? So I made it smaller in this page. 1, 2, 3, 4, 5 unknowns, unknown variables. Okay, so basis Here is 100. You already have S's. Second, draw the flow chart. Third, you have knowns and unknowns, right? Okay. Well, sorry, I think I missed one information. The one of information is that the dry air, the ratio of the dry air and water, the ratio of the number 5 is equal to the ratio of number 4, right? So you know, ratio of number 5 is ratio of number 4. The ratio of number 5 is ratio, that's right? Ratio of number 5 is equal to ratio of number 4. And you have 5 unknowns. Okay, so let's do the DLF. So if we have overall, let's do overall first. Always overall first. So always overall, so how many input and how many output? Overall means that this recycled stream is inside the box. Right? Inside the box. The hypothetic box. So how many input and how many output streams? 1 input stream and 2 output streams, right? This is 1 input stream. These are 2 output streams. And how many unknowns? 1, 2, right? 1, 2. So you have 2 unknowns. How many? You have 2 unknowns, right? You have 2 unknowns. And how many equations? You can have 2, right? Dry air and water. So bingo, you can solve N1 and N3. Okay? Can you do that? Can you do this simple calculation for me? Yes, you can. Okay, and then we go to mixing point. So you go to N1 and N3. How about you go to mixing point? Mixing point here. So you already got the answer of this one and this one. So how many input and how many output? 2 input, right? 1, 2 in this mixing point. How many output? These streams. 1 output streams. How many unknowns in this case? 1, 2, 3, right? No. It become 1, 2. Why? Because you just get the answer of this number 1. So you have 2 unknowns. So you can get the answer of number N5 and N2. Okay, so you already get one. You already get answer of this one, this one, this one, this one. Can you get answer of this one? Yes. Okay, so you just do the air conditioner. So you already get answer of this one, and you can get answer of this one. Okay. Are you with me so far? Are you with me? No? Yes? No? Okay. Go home and practice. And if you don't, you are welcome to come to me. I will personally told you, okay, in Chinese. So what I want to let's do it again. How if you do N1, N3, right? So this is N1, N3. So you get an answer of N1, N3. Is that right? Again, overall, right? Overall. 1 input stream, 2 output stream. So you have 2 unknowns. And you can create 2 equations because dry air input equal to dry air output. Water input equal to water output. Okay? So you have 2 unknowns, 2 equations. Bingo, you got N1 and N3. Okay? And then once you got N1 and N3, let's go to the mixing point. Mixing point is you have mixing point. Now you have 2 unknowns, N5, N2, right? And then how many input stream? 2 input stream and 1 output streams. And then how many equations? 2 equations. Because you have 2 unknown, you can have dry air input equal to dry air output, 1 equation. Water input equal to water output, 2nd equation. So you can get N5 and N2. So I make it become from red color become blue color. Okay, and then go back to air conditioner. Is that 1 unknown, number 4 is easy, right? So you just get the answer. Right, so please do the calculation. And the thing is, if you don't have recycled stream, you cannot get this comfortable air come out from your air conditioner. You will get more wet water because of the efficiency of air conditioner. Okay, this efficient conversion is not that good to make water from 4% to become 1.7%. It can only from 2.3% to become 1.7%. Okay? Right. Do we have time? Oh no. I think the clock is a little bit slow. But anyway, okay, so that's it for today. So please go home and have a piece of paper and pen with you. Do the simple calculation, okay? This is not difficult.